Welcome back. All right, in this video what we're going to be doing is taking a brief look at control structures. Logan?
All right, to begin with, let's jump right in and first address, well, what exactly is a control structure? Well, in programming, we're simply talking about conditional execution. A control structure is a programming construct that allows you to execute a statement only when a specific condition is met. This allows a much more advanced program, as your program can react to any given scenario that you would like.
Well, having a program that does not have the ability to make decisions really limits the program.
Exactly. Now, the three major structures we're going to look at are if, else, and elif. These are the basics, or the building blocks, that we're going to use to build control structures.
Okay.
So right off the bat, what we're going to do is jump into a new Python script and begin editing it with idle. So, of course, we're going to do this by grabbing an empty document, which we will call control structures. So control structures.py. We'll load that up in idle. And the reason I'm doing this here is since, once again, when we're talking about control structures and conditional execution, we're talking about multiple statements and things where we would want to have an entire block of code visible and on screen, as opposed to typing it out line by line in the interactive interpreter. So to get started, let's make a very simple scenario where a line of code is only executed in an active scenario. Let's pretend we're making a machine or a system, and when the imaginary system in question is active, a line gets shown to the screen. Otherwise, it does not get shown to the screen. So let's make the condition first. Let's actually make a Boolean value and store it in a variable. We'll make a variable called active, and we'll set it equal to true. Then we'll turn around and we'll begin a control structure using an if. And we'll say if active, then end with a colon to specify that we're now starting an indented code block. We'll jump down to the next line and print anything that we'd like to see shown to the screen. So something like system is active. So very simple, but once again, the whole idea is that this print statement is now executed conditionally depending on the value held in our variable. And at this point, it would be good to point out the fact that the control structure if is based off of Boolean values. Now, as you'll see shortly in the later part of this lesson, we are going to get into more complex expressions that are evaluated to give conditional execution. But the key is that that expression is always boiled down to a simple true or false value. So that's the key here, is that the if is only worried about execute or don't execute. Now, let's run and see what the result we've got here, because remember, active is currently true, and if true, we should see text on the screen. So we run, and we see the line showing the fact that the system is active. Very good. Now, simply by changing the value of this variable, we can change how our code executes. So if we set active to false, we see that nothing is shown out to the screen. So once again, the base concept here is really very simple. We're only talking about executes or does not execute, true or false, therefore Boolean checking. Now, to take this concept a little bit further, let's see what would happen if we wanted to tell whether or not this line had executed. Because let's say that another more important statement had been run following this print statement. If we wanted to check whether or not that would have run, we can basically make a handler for the opposite value, meaning if this value is true, we of course run this line. We can use an else clause to provide execution of lines in the case that the test came back as false. So we can drop an else in place and print out another message, something like system not active. And this way, regardless of what value is given, we will see something shown to the screen. So if we run at this point system not active, if we set active back to true, then we get system active again. So this way you can have, the execution of each of these lines is still, of course, conditional, but we can have different code paths depending on which actual value was present. And one other thing to point out is just like with any standard Python syntax, this is an indented code block, so one could put as many statements as they wanted to without having to worry about further syntax. So we could do something like another print statement saying, also the system is on. And then we could go on and do something like print out a simple expression. So we could say 2 plus 2 equals, give a comma, and then actually run that expression. So once again, in this case, blocks of code are simply treated by indenting. Alright, now we've seen an if and else, so we can do a simple two-path branch. Now what if we wanted to be able to test for more scenarios? If we wanted to test not only the state of active, but let's say we wanted to also consider other variables or other values. Well, one could go about building additional if and if-else statements, but you would run into a scenario where you would potentially be doing unnecessary checks, because if a check came back is not active and you wanted everything to be considered as part of the same check, you wouldn't want to have a scenario where both active and not active were checked at the same time. So what we're going to do now is we're going to take a quick look at the elif construct. Elif is basically just a combination of else and if. So basically, if something was checked, then we run that line. If not, we'll move on to any elif checks. And then if the elif check comes back as false, then we finally drop down to the else. So elif is similar to if in that we need to put a Boolean value in place. So let's gain another variable as something else to check. Once again, I'm just using simple Boolean variables here so that we don't yet have to get into complex expressions to resolve. We'll make another variable called, I don't know, how about on fire? And we'll set that to false for the time being. So we'll say elif on fire, then we'll print out that the system is on fire. Of course, if we run right now, active is set to true, on fire is false, so we should be looking at the first line. If we run, it does indeed show the first line of code. If we change this now so that active is false and on fire is true, and we see that the system is on fire. So what has happened now is we hit the first line in the control structure and we see that if active, active is false. Then we move down to the elif. Is on fire set to true? It is. Therefore, this line got run. Now, if we set both of our variables to false, what's going to happen? Well, active is false. We don't run this line. On fire is false. We don't run this line. And so we finally drop down into the else because neither of these conditions were met. So we should see that the system is not active, as we see here.
Okay.
And really, that's about it as far as the base construct of a control structure goes.
Well, the whole elif thing is very useful when you know that there might be several possible conditions that could happen. One good example is the old Coke machine thing, where basically you write a very simple application to represent the handling of coins that have been dumped into the machine. So you could say, if it's this, else if it's this, else if it's this. So you could say if it's 25 cents, else if it's a nickel, else if it's a dime, and then finally just dump out with the else, the final else being, well, obviously it wasn't one of those, so just dump out.
Exactly. The whole point being that you could sit here and write additional elif statements to your heart's content, as seen here. So
And in this case, we're looking for a bunch of possible scenarios that we know could occur. And if one of those particular scenarios did occur, there was something very specific we wanted to have execute within our code.
And another key thing here is that if any of these checks comes up true, only the statements belonging to that check's code block is what gets executed. So that if on fire was true, we would not see this line executed, we would not see this line, and we would not see the else. We would only see that one.
That's right.
That's one of the nice things about this kind of control structure is it's very easy to see what's going to happen. If this one case is true, only this case's code block executes, nothing else, and then the entire remaining lines are skipped until we drop out of the entire control structure.
Exactly.
All right, so let's move on from here and talk about some comparison operators. These are some operators that are very useful when used in conjunction with control structures, as they allow you to test more complex scenarios. As we've seen so far, we're only using very simple Boolean values, And it would be helpful to be able to check things like, is a certain number met? Is a string equal to the string that we're looking for? Is a numeric value within a range? So, what we're going to do is very briefly jot down some of the common comparison operators that would be useful for us to use. So, these are common comparison operators. And these include the is equal operator, the is not equal operator, the greater than operator, the less than operator, the greater than or equal to, and the greater than or excuse me, less than or equal to operators. These are all very useful. Equals and not equal to, useful for just about anything, numerical values, string values, and so on. Greater than, less than, greater than, equal to, and less than or equal to are generally used with numeric values. That's not to say that that's the only things that can be applied to, but those are generally the most common uses of such operators. Other potential data types might have useful numeric values they would resolve to, but we're not going to delve into things that deep just yet. So, with this in mind, let's go and take a quick look at one more thing I want to talk about with control structures before we get completely away from the simple stuff. Now that we can use greater than and less than, I was saving this last example with the if statement. What I wanted to show was the idea of nested if statements, but I wanted to have some more interesting values to show in regards to that. Actually, our first look at a simple range check. So let's take all of this code, wipe it off the board, and let's drop something new in place. Let's begin with a variable and store the value 8 into it. And then let's set up a scenario so that we can tell whether or not it's between the numbers 5 and 10. So to begin with, to see if the number is between 5 and 10, first we need to check one side of that range. So let's start with the lower side. Let's see if a is greater than some given range. Let's do between 5 and 10, so we'll begin with 5. So if a is greater than 5, let's print out a line of text to indicate that. So saying a is more than 5. So easy enough. We can run from here just to build this incrementally. So we can see that, well, a was 8, so of course it is more than 5. Now, let's show something interesting with code blocks and indentation using if statements. And that is the fact that we can nest if statements within other if statements. So still indented at the same level as the print statement. Let's do another check. Let's see if a is at this point less than 10. And if it is, let's print
10
out,
or 20.
Oh. Yeah, good catch. I wasn't even looking at the keyboard. If it is less than 10, we'll confirm that with a line of text saying a, actually let's do this both since it's nested. We'll write this out as also a is less than 10. Simple enough. If we run, we see that both lines are shown. A is more than 5. Also, a is less than 10 because both conditions were met. Now, here's something interesting though. This is not the best way to go about doing a range check because this if statement is itself conditional because it exists within the first if statement. So that means we could do interesting things like if we set a equal to 2, 2 is less than 10. That means this check would be true, but we're never going to see this line of code executed. If we run, we see nothing shown, and that's because we didn't meet the first requirement, and that is a being greater than 5. So therefore, we never even ran that check.
So we could potentially run into situations where we're wanting to write our code in such a way that we could account for a being greater than 5, do one thing, or perhaps if a is less than 10, we're going to do something altogether, no matter if it's greater than 5 or not.
Exactly. Now, where this type of scenario would be more useful is if you want to have checks done only if it is worthwhile to do them. For example, we could spend a bit of time and go back to our original examples of active and on fire. This might make a little bit more sense just to read it all out in English. So active equals, let's say true, and on fire equals true. So this is almost kind of like prioritizing the checks. So let's begin by saying if on fire, and instead of checking the value directly, let's use the is equal to comparison operator. So if on fire is equal to false, that means that if the system is on fire, we're not even going to bother checking if it's true. There's no reason to. It's on fire, so we have worse problems. So only if on fire is false do we continue on and do a subsequent check. And in that subsequent check, we can say if active equals true. Now, of course, as we'd seen before, we don't necessarily have to do the comparison check with true. It resolves to true by itself. But again, this just this allows us to read everything out directly. And very briefly, I'm going to update the text so that it makes sense in the context of our updated code. So if on fire is false, we can say system is not on fire. And if active is true, we can say, once again, system is active. So both are set to true, including on fire. So let's see what happens. We run, we get no output whatsoever.
Well, this would be a good place to demonstrate how we could still put an if sitting in for the very first, an else, excuse me, for the very first if. So we could say if it's on fire, false, else, which is going to be outside the nested if, which belongs back to the original if, hopefully that didn't sound too confusing, that then simply says, it's on fire.
But we can very easily show that. We can do just that. Let's jump back, so jump our indentation all the way back to the beginning so that we are at the same level as the original if statement. And let's put in an else clause. Else will print out and say, we have worse problems. So once again, with on fire being set to true and run, we have worse problems. We haven't even considered the system's active state.
That's right.
So let's turn on fire off. So the system is not on fire false. Active is currently set to true, and we see that the system is not on fire and that the system is active. Of course, to show all possibilities, we could set both active and on fire to false and run, and we still see the fact that the system is not on fire, but it's not active. Well, once again, this else hasn't been triggered at all because on fire, false. Continue to here. Active, also false. We skip over this line. We also skip over the else because we met the first scenario, and we drop down to
continuing on. So this is also a good place to demonstrate that with embedded ifs, we can also have embedded elses. So if it's active, true, else, and this is within the first if, we can say else print system is not active.
That's true. Looking at this outside structure of the if followed by the else, there's no reason we couldn't do that nested using this if statement. Let's drop down after we have displayed the fact that the system is active, put in an else clause, and then print out system not active.
And the nice thing about this is I think we have accounted for all possible scenarios, so we're going to get feedback no matter what state we're in.
Exactly, for all possibilities. Well, we can see that there's 4 different things that can be shown, and in some cases multiple things can be shown. But like you said, no matter what, we'll always get indication of what we're looking at.
The big thing is just keep in mind when you're dealing with indented ifs and elses, it's all about the indentions.
Exactly. All right, let's move on from here and take a look at some Boolean operators. We're going to look at or, and not.
Okay.
What these operators allow us to do is they allow us to do compound checks. So that means in the case of just a single if statement, we could check for ranges, we could check the values of multiple operands, and so on. Now first, to introduce these and exactly what happens as we run them, I'm going to switch over to the interactive interpreter so that we can see stuff as we type it. Once again, the operators we're looking at here, let me jot these before we go any further. Let me just jot this down. Boolean operators. These are going to be or, and not. So, as their name suggests, these are generally used in the Boolean sense, and that we're going to use them, for example, with if statements. So meaning check one operation or possibly another operation and get a result from that. Now to demonstrate what we're looking at, I'm actually going to use true and false literally on the interactive interpreter. You could imagine these being similar to active and on fire as seen earlier, but just to show the results and the idea of them. First we're going to address the OR operator. And the idea of the OR operator is that if either operand is true, true is returned. So something like x or y, what's going to happen in this expression is if x is true, we simply return whatever x was, and we don't look any farther. If x resolved to false, then we move on and we test y. If y is true, then we go ahead and return it. But if neither return to true, then we return false. So that way it's well, just like in a logical gate, in that if either operand is true, then we get true. This can be demonstrated here on the interactive interpreter. If we said something like true, and once again I'm leveraging the fact that the true can literally be typed into the interpreter, so if we type true by itself, that actually gives the value true. So we can say the result of the operation true or false. What does that return? That returns true. Because once again, true was checked, and we didn't have to go on and check false.
Basically, we short-circuited out and got true.
Now we can do this the opposite way. We can do if false or true, and we still get true. Even though we first did a check and the first operand was false, we still went on and looked to see if there was another operand that was true.
And if either or are true, then we get true returned.
Hence the name. Now, of course, if neither operand or true, then of course we're going to return false, meaning if we say false or false, that is really false. There was nothing we could get true out of. Neither operand was true, so we returned false. Now, let's spend a minute and take a look at the AND operand. Very briefly, let's write that up here on the board and say if x and y, and see how this would evaluate. Basically, with the AND operand, you always have to consider, or excuse me, with the AND operator, both operands have to be considered, meaning we would check, is x true or false? And if it's true and y is true, then we return true. If either are false, then we return false. So technically we don't have to check if both are set. Again, this makes more sense if we're back on the interactive interpreter. So let's take a quick look. So true and false. Are both true and false equal to true? Well, no. False is going to be false.
That's right.
So the result is false. All right, let's try the other way. If false and true is also false, because once again we have one side was false, therefore the entire expression or the entire result was false.
I mean, in the end, it really is logical and straightforward. For those of you that are watching, if there happens to be a complete newbie out there that hasn't been involved with programming that much and you find some of this confusing, just think of it like this. If I'm hungry, I'm going to go to the kitchen. If I'm thirsty, I'm going to go to the kitchen. Now I can start getting fancy and combining these things. If I'm hungry or I'm thirsty, I'll end up in the kitchen. So in either case, I'll go to the kitchen. Now if I was to switch out the or for an and, when would I end up in the kitchen? If I'm hungry and thirsty, go to the kitchen. So the only way I would end up in the kitchen would be if I met both of those conditions. I was hungry and thirsty.
So under that mindset, if you're sitting at your computer thinking, I'm hungry, but I can't go to the kitchen because I'm not thirsty
That's
yet.
right. Need both. So yeah, it really is straightforward and easy to visualize when you think of it like that, kind of in a real-world sense. And the interesting thing is we can start building very complex expressions with the use of these different operators.
And just to finish this off, of course, true and true does indeed return true.
Right.
So both hungry and thirsty at the same time is the only value.
Off to the kitchen.
And that we go off to the kitchen.
Not that I'm hungry right now. All right, maybe just a little bit.
All right, let's take a look at a practical example using some Boolean operators. Let's jump back into idle for a minute, and let's draw up a new example. Let's begin with the variable a and set it to the value 8. Now, let's do a more complex check using an if statement. Let's say if a is greater than 5 and a is less than 10. If this is true, then let's print out to the console and say that a is between 5 and 10.
Yep. So there you have set up a very nice range checking scenario.
and more simplistic than our earlier nested scenario.
Absolutely.
So if we were to run and check this, we see that, yes, A is indeed between 5 and 10 because it's 8. If we set it equal to 2, we get no output. If we set it equal to 20, we get no output again, once again, because it's outside of that range.
That's right.
And it's made much easier because we can do compound checks by simply taking the results given here and doing a check on those using AND. So, moving on from here, let's set up another example. Let's do the opposite of this kind of range check. Let's make sure that a value is outside of a given range. So let's change up some of the values here. Let's say we'll set A to 3, and we'll make a new comparison. We'll say that if A is less than 5 or A is greater than 10, then we can say A is outside of 5 to 10, so outside of that range. So if we run now with A set to 3, we do get A is outside of 5 to 10. If we set it up higher, such as 20, still outside of 5 to 10. If we set it to something like 8, we get nothing because we did fall inside of
very interesting thing to note here is by changing the way the logic works, we were able to take it from an inclusive to an exclusive type scenario.
Exactly. Also note that fewer checks have to be done in this case. The idea of swapping out to an OR here means that the moment we noticed that the first operation returned false, the moment we were less than 5, we didn't have to check to see if we were greater than 10. We knew that if we were less than 5, we're already outside of that range. We don't need to go on and check the rest of it.
And that's right. It's smart enough to know that with an OR, either of our two expressions there need to evaluate to true to result in a true value. And since the very first one evaluates to true, hey, there's no reason to keep on going. Let's go ahead and execute the code for this if true was indeed the result.
All right. Well, that takes care of the AND and OR operators. Now let's move on to the NOT operator. And the idea of NOT is simply a negation operator. It takes any Boolean value and inverts it. So basically, if you have a true statement, and if you say not true, that would result to false. Not false would reverse back to true. And we can go and literally test this out on the interactive interpreter. Not true is false.
If it's not true, it must be false.
And not false, true. So
and
once again,
if it's not false, it must be true.
You can just think of this in English, in terms of English, and it would make perfect sense.
But again, very handy.
So let's take a quick look at that, going back to some of our if statement examples, and set up a scenario where using not can shorten the amount of code necessary to accomplish something. Let's set up our active and on fire variables again. And we'll set active equal to true and on fire set to false. Now let's set up a check where we want to make sure that everything is good. We're not going to do checks that were as in-depth as our nested scenario where we had all 4 scenarios covered. Let's just say that we're not worried about the individuals. We're just saying, are we good to go or are we not? So let's begin an if statement. And let's consider the values active and on fire. So basically what we want is to make sure that we are active and that we are not on fire. And if you break that down English word by English word, you've pretty much got the if statement. So if active and not on fire, then we can say print status is good. Else, print status is not good. And leave it as simple as that. So with active, true, and on fire, false, we run and we see that I have omitted the colon to indicate our code block starts here. So correct that small syntax error, and we can continue and see that the result of this script is that the status is good. We are active and we are not on fire. The moment we change the system to be on fire, we see that the status is not good. So being on fire, very much not good. Or let's say, okay, we go back to not being on fire, but we set active to false. And run, status is still not good. We're not on fire, so it's not that bad, but we're still not active, so it's not good.
That's right.
So once again, this gives a much cleaner shorthand, given that we only need to say a good or bad result.
Plus, it's very readable, too. If it's active and it's not on fire, do this. Otherwise, do that. I mean, it just makes sense.
And let's see, one last thing I want to point out, though the examples that I'm going to show it in aren't necessarily requiring it, but I did want to very briefly mention order of precedence, meaning if you weren't sure what gets checked first. Are we checking active and something, or which side is checked first? We can always use parentheses to specify how the order of precedence should work, much like in a mathematical operation, where you have certain operators that have an order of precedence and you want to control that further. The rules here work just like they do in the mathematical sense. So if you're running into a scenario where your operand is checking, or your operator is checking the wrong operand, just use parentheses to block it in. Of course, here this isn't changing the meaning of anything, because it was already checking this if active was being checked by itself, and not taking higher precedence was already checking on fire first.
Right.
Once again, just pointing out that when you run into a scenario where you need to control the order of your operation and how everything is checked, you can simply use parentheses. Alright, that has addressed all three of our operators, but there's one last thing that I want to point out before we close out this lesson, and that is the fact that the OR and AND operators actually return the results of an expression, while the NOT operator only returns Boolean. Now this may seem a little confusing, and at this point, really it's not absolutely vital that you grasp this concept. Up until now, you can simply view everything in a purely logical sense, and you'll be completely okay for using these in any practical scenario. Though there are some interesting things that you can do if you do differentiate between their return values. Let me give an example of what I'm talking about. If we go over to the interactive interpreter, what I want to point out is the fact that both AND and OR operators actually return the result of a given expression. What this means is we could use non-Boolean values in conjunction with those operators. Let's take a look at this. So it'll be confusing at first, but we'll go through it and explain it step by step. What about the operation 4 or 5? Now logically this doesn't make sense because we're not talking about Booleans, yeses and nos, but 4 or 5, does that even resolve? It does. Not only does it resolve, but it's returning a non-Boolean value. We're actually returning an integer 4 out of that operation. So what on earth is going on here? Why are we getting a value back? Or how is it even, under what logic is it comparing this? Well, what's interesting is the operation is still Boolean. What happens is the operands in question get converted to Boolean in order to be tested. So what has happened here is you could almost envision convert to bool the value of 4. That converts to true. That's why our entire expression resolved, because one of these returned to true. The interesting thing here is that OR actually returns the result of the expression, not necessarily the Boolean value. Now you might be thinking, it's like, okay, well, what are the rules here with this Boolean conversion? Well, you can preview what would happen with any given value by simply converting that number yourself. So the Boolean value of 0 would be false. Also to note, as you're using this, of course, more than integers can be checked. You can also check strings. Also, the Boolean value of an empty string is also false. But generally, anything else numerically, like negative numbers, those would be true. Anything non-zero would generally be true. And any string that was not empty would be true. So if we said get the Boolean value of cat, okay, well that's not empty, so it's true. Now, an interesting thing that can be done knowing this is we could set up a scenario where we could gather input from a user and then specify a default value if they enter nothing. So let me give an example of this. What we're going to do is we're going to use the raw input function to gather input from the user. To give an example of this, let me make a quick variable called user data and set that equal to the value of raw input. What's going to happen when we execute this line is we're going to be left at a prompt. You'll notice we haven't dropped back to the three forward slashes. So what it's doing is it's waiting for input. So if we gave some form of input, we return back, and now we can look inside user data to see that user data holds the value cat. Very good. Now if we go back and run this line again and simply hit enter, user data now contains an empty string. And we'd like to very quickly set up a scenario so that we never get an empty string back. We could use an OR operation. So we could say something like user data equals raw input, or give the string default. So what will happen now if we run this and then give nothing and look inside user data, we have default entered. So this may seem confusing of why on earth can you write things this much in English and still get a valid result, but let's look at what's happening. First we look at this operation of raw input or default. Well, raw input ran, we gave it nothing, an empty string, and we've already seen that an empty string is false. So what happened is this side of the OR statement was false. So we considered the right side. Or default is not empty, therefore it's not false. So it was the value that got returned. So in the case of empty input, we get default. In the case of any other input, like cat, user data holds cat instead of default. So it's just a really interesting way that you can leverage the fact that OR and return the result of the expression. Now it should be noted that the not operator always returns true or false. So saying something like not 5 is false. Why is that? Well, if we look at the Boolean of 5,
we see it's true, and
so
not true is false.
Exactly. So keep that in mind. Even if you use not in conjunction with a non-Boolean value, you're still going to get a Boolean value back. Because once again, just like with OR and, the value gets tested as a Boolean, but in the case of not, it also gets returned as a Boolean. So we're actually returning the opposite of the Boolean conversion of 5. So again, getting a little bit deep there, but just wanting to point out that that is in fact the way things are working. So if you ever get muddled in a very complex scenario testing for Boolean values, just keep all of these things in mind and how they work. And once again, if you don't take interest in how you can shorthand things with OR operators, you don't really have to worry about the return values, because things will generally just get considered as they need to get considered. So if you always want to treat these in their purely logical sense, that's perfectly fine. Just wanted to point out that this is what's going on under the hood. Now with all of that, I believe that is going to bring this video to an end. Once again, we're simply taking a quick look at control structures. We looked at if, elif, and else to control what statements get executed, and then we took a look at some Boolean operators that can be very helpful to us when testing various scenarios. So with that, that is going to wrap up this video.